So let us continue with exercise 1.5. So we will solve the fifth question of exercise 1.5. Rationalize the denominators of the following. The first one is 1 by root 7. Here you can see the denominator is an irrational number. So we should solve it such that without changing its value, denominator should be made rational. Denominator is irrational, so we have to make it irrational. So for that, whatever is the denominator, see here, this denominator is a monomial, a single term. So multiply and divide by the same term. Okay. So we will multiply by root 7 and divide by root 7. What is 1 into root 7? 1 into root 7 is root 7. What is root 7 into root 7? Inside multiply, 7 sevens are 49. So what do you get? Root 7 by 49 square root is 7. So you can see the denominator is rationalized. It is not an irrational number now. Okay. Let us see the second sub question of this. We have to rationalize this. 1 by root 7 minus root 6. Here you can see it is a binomial, isn't it? So since it is a binomial, let us multiply and divide by its conjugate. Conjugate means if there is a minus sign in between in the denominator, take a plus sign. And if there is a plus sign, take a minus sign. Since there is a minus sign here, take plus sign. So multiply and divide by what? Root 7 plus root 6. Okay. Now we will continue on the next line. 1 into root 7 is root 7. Numerator I am solving. 1 into root 6 is root 6. Denominator you can see. This is of the type root 7 plus root 6. Root 7 minus root 6 means it is of the type a plus b into a minus b. And the multiplication of a plus b into a minus b is what? A square minus b square. So a is root 7 here, b is root 6. So a square will be root 7 square, b square will be root 6 square. So numerator remains same, root 7 plus root 6. Square root goes, what remains? 7. Square root goes, what remains is 6. So root 7 plus root 6. What is 7 minus 6? 7 minus 6 is 1. So this is the final answer. So the third sub question in this is 1 by root 5 plus root 2. Here also you can see it is a binomial. So what you do is you multiply and divide by its conjugate. Conjugate means if there is a plus sign, take a minus sign. Just take opposite sign. Keep the numbers same. Okay, root 5 minus root 2. Since there is plus sign in the denominator, I am multiplying with the minus sign. And both these signs should be same. Even in the earlier problem, you can check it out. Okay, so numerator 1 into root 5 is root 5. 1 into root 2 is root 2. Denominator is always of the type a plus b into a minus b. A plus b into a minus b is what? A square minus b square. A is root 5, its square. B is root 2, its square. So numerator remains same, whereas denominator square root goes. Square root goes. So root 5 minus root 2. 5 minus 2 is what? 3. And this will be the final simplified answer of this. Now the fourth question in this, you can see, the question is 1 by root 7 minus 2. You can see here the square root is only for the 7 and 2 is independent of the square root. So let us solve this question. Okay, since it is a binomial again, let us multiply and divide by its conjugate. That is minus sign is there, so multiply by plus sign in between. Keep the numbers as they are same. So numerator 1 into root 7 is root 7. 1 into 2 is 2. This is a minus b into a plus b. a plus b into a minus b is a square minus b square. A is root 7, so a square is root 7 square. And b is root 2, so b is just 2, so it will be 2 square. So let us solve it further. Okay, so it becomes root 7 plus 2 upon square root cancels, you get 7 squares. 2 square is what? 2 square is 4, because we don't have a square root sign here. So 2 square is 4. Here we have a square root sign. So square root and square will cancel. So it becomes root 7 plus 2. 7 minus 4 is 3. So this can be the final answer of this. So let us solve few additional examples. So the first question is in that, here in the following examples, find the variables x, y, z, etc. which represent rational numbers and which represent irrational numbers. So we have to just find out the variables, solve for the variables and just state whether they are rational or irrational. Okay. Now first one is x square is equal to 5. So what will x be equal to? We have taken out the square, so we have to put square root. So what is this, rational or irrational? It is irrational. Okay, the second one in that is y square equal to 9. If y square equal to 9, then y will be equal to what? You have taken the square, so you have to put a square root of 9. What is square root of 9? 3. 3 is rational or irrational? It is a rational number. Okay, let us see the third sum now. Third sum is z square is equal to 0.04. So what will be z equal to? Square root of 0.04. And if you find the square root of 0.04, it comes out to be 0.2. And 0.2 is a rational number because 0.2 you can represent in the form of 2 upon 10. 2 by 10 is 0.2. So it is again rational number. Now fourth sum. U square is equal to 17 by 4. So u will be equal to under root 17 by 4. You don't know the square root of 17, so it is root 17. But you know the root of 4. Root of 4 is 2. Okay. So numerator is irrational, denominator is rational. So it becomes an irrational number. Now fifth sum. V square is equal to 3. So what will be V is equal to root 3. So root 3 is irrational. Okay. Then next is W cube is equal to 27. So what will be W is equal to? You have taken off the cube here. So you have to put a cube root. And cube root of 27 is 3. And 3 is what? Rational number. So the seventh sub question in this is r square is equal to 0.4. So what will be r is equal to? Root of 0.4. And we don't know the square root of 0.4. So it is an irrational number. We need to actually find out the square root by division method, which you have learnt in 8th standard. Okay. So it is again irrational number. Now we will just stop here for today. Okay, take down all these notes, practice these sums. Okay, take down the notes in your fair book, practice these sums again and again by understanding and writing and solving them again and again without looking. Do not ignore, please. Okay, do it for your parents' sake and for your own sake. Thank you.